When you apply fertilizer on land, a lot of it actually ends up not in production, but is a runoff. Either it is going into groundwater, entering streams and rivers that eventually go into the ocean. These nutrients have the same effect of increasing the growth of phytoplankton, which are single-cell plants that live in the water. The things that control the growth of phytoplankton, nutrients and light. So where you have enough light in the water, you have the growth of phytoplankton. The increased use of fertilizer and running off into rivers is now causing the growth of phytoplankton. The global distribution of nitrate transported to the oceans in most places is mostly biological. But then in many of the industrialized nations, or where there's a lot of farming, it is actually fertilizer that is the major source of nitrogen that is being transported into the ocean. Now you have this river water that's coming in that is rich in nutrients that is being delivered to the ocean, and you have phytoplankton that live in the ocean that take up the nutrients that is then eaten by zooplankton, by fish. Eventually, when the phytoplankton dies, it goes down to the seafloor where this is then consumed by bacteria which respire. Under normal conditions, you will have mixing of oxygen from the surface as well as oxygen being produced by photosynthesis that keeps the water well oxygenated. However, if you have a system, as often happens in the northern Gulf of Mexico, but many parts of the world, where the mixing of the surface waters and the bottom waters are restricted in some fashion, often due to temperature. It happens in the summer where warm water is light, cold water is heavy, and you don't have the mixing. So you have cold, oxygen-poor waters sitting on the seafloor, and it's not mixed with the oxygen-rich waters near surface. You end up killing all the life on the seafloor, causing what we call dead zone, which basically has a pretty big impact on fisheries in the Gulf of Mexico. This is a globally pervasive problem.